Hey there! In this video we're going to be talking about sprite sheets. We'll discuss what they're used for, why we use them, and then finally how you can use sprite sheets yourself in Pygame. Many games involve taking a series of images and putting them onto our computer screens. If you have a game with a lot of images, the amount of draw calls and rendering that you'd have to do to load them all in can be quite expensive, and this can cause performance issues. To get our game running efficiently, we as programmers need a way to access these images as fast as possible. Lucky for us, sprite sheets are a great solution for this problem. Rather than loading up dozens or even hundreds of images, we can package them all up into just one single image. So it's only going to be one draw call and one texture per sprite sheet that you're going to have to worry about, which is awesome. What we have here is a simple sprite sheet. And this is a small little program I made in Pygame that's able to iterate through all the images in our sprite sheet. I'll show you how to make a sprite sheet class that will allow you to achieve a similar effect in any new or existing project you're currently working on. If you want to follow along with me and use the same images that I'm using, I'll leave download links to everything in my GitHub. If you have your own images and you'd like to make your own sprite sheet, you can do that with a lot of different programs. Personally, what I use is Texture Packer. You can get a free trial from their website, and then after that it's $20 to keep the program. I'm not in any way affiliated with Texture Packer, I'm way too small a YouTuber for that, but it's just what I use and it works for me, so if you want to try it, give it a go. And just as a quick note for everyone who is using Texture Packer, if you want to follow along with everything I do in this tutorial, make sure you use the JSON hash output. Setup-wise, we're going to have 4 files that we're going to be working with. Spritesheet.py is going to have our sprite sheet class, and we're going to make that in a second. Test game is just going to be a simple game loop that we can test our sprite sheet with and make sure everything's loading correctly. Trainersheet.png right here is going to be our sprite sheet, so we can see what it looks like right here. And then finally, we have trainersheet.json. And what this is the metadata for our sprite sheet. So if we take a look, let's open it up, we can see exactly where all the images go. For example, the first frame, trainer1, is at x equals 0, y equals 0, and then has a width of 128 pixels and a height of 128 pixels. This metadata is what's actually going to allow us to take our pictures from the sprite sheet and cut them out correctly. As I said before, a test game is just a really simple game loop. Right here, I just make a window, and then I create my game loop while running, check my players' events, and then what's going to happen is if they press space, we're just going to iterate through the sprite sheet and go image by image, and at the very end, I update the window. If you're not super familiar with game loops and want to learn more about them, you should check out my menu system tutorial. But for now, let's go ahead into Spritesheet.py and get started on our sprite sheet class. So we're going to start by importing Pygame. And now let's go ahead and declare a sprite sheet class. Usually the first thing you do when you declare a new class is make the init function. So let's go ahead and do that. And in this case, we're going to pass in an argument, file name, and this is just going to be the name of the file that contains our sprite sheet. Let's assign a variable inside the class to keep track of this file name for us. So we'll do self.filename equals file name, which is the argument we just passed in. Now that we have our file name, let's go ahead and load in our sprite sheet. To load in our sprite sheet, we'll assign it to a variable, self.spritesheet, and then we'll do pygame.image.load. This is Pygame's way of loading in images, and as an argument to this function, we can just pass in our file name. Now there's one more thing we're going to want to do here. We're going to want to put .convert, and I'll explain why. In our test.game file, we have this window, and this window uses a certain pixel format. If the pixel format between our window and our sprite sheet don't match up, then we're going to have to convert that image every time we blit it onto our window. This means extra calculations we have to worry about, and this can really slow our game down. Instead, we can convert it as soon as we load in our sprite sheet and then not have to worry about any extra calculations. Now let's go ahead and make a new function. And we're going to call it getSprite. We're going to pass in an x, a y, a width, and a height. And what this function will do is it'll go into our sprite sheet, and then it should match up with the metadata here, and it'll get the image and cut it out correctly. We're going to go ahead and create an empty surface, which you can just think of as a blank slate for where an image can go. And it's going to be the same width and height as the sprite that we're trying to get. We're going to go ahead and store this in a local variable sprite. Now, if you're dealing with transparent images like I am, you're going to need to set a color key. Setting a color key is one of the ways we can handle transparency. The way it works is that we set a specific color to be our color key, and then at runtime, that color isn't blit onto the screen. If we go ahead and look at our sprite sheet, the checkerboard pattern is actually just made up of black pixels. So if we set our color key to black, then at runtime, it won't compute those black pixels, and then it'll just show what we wanted to show. Just to make things a little more clear, 000 is full black. If we take a look at our trainer here, there is black on the trainer, but it's not full black, so it'll still show. You can put in whatever color you want here depending on how you make your sprite sheet, but I've seen most sprite sheets use 000. The last thing we need to do in our function is just cut out the sprite. So to do that, we can do sprite.blit. Using the blit function, we can take our empty surface and paste an image onto it. So our first argument is going to be where we want that image to be pasted from. And we're going to want to take it from our self.spritesheet. As our second argument, we're just going to put in 0, 0 just to align it where we want it to be. Then lastly, we're going to put in X, Y, W, and H. And this will tell it exactly where to look and exactly how big and how wide we need to cut our image. Now that we run the blit function, our empty sprite surface now has the image that we want. So the last thing we can do is just return that image back. Let's go back into our test game function just to make sure everything's working properly so far. Let's start by importing the class we just made. So we can do from spritesheet, import spritesheet. Let's go above our game loop and let's actually create a spritesheet object. We'll do equals capital spritesheet. Then as an argument, we're just going to pass in the file name of our spritesheet. In this case, mine is called trainersheet.png. Let's attempt to blit the first image on our spritesheet onto the screen. So we're going to do trainer1 and then we're going to equal. Now we'll do my spritesheet and we'll do .getSprite. Now we're going to need to enter the coordinates and dimensions of our image. So if we go into our metadata, trainersheet.json, we can see it's 0, 0, 128, and 128. So we're going to go ahead and enter that into the getSprite function. The function will get the image and return it and store it into trainer1. So after this, to test it, all we have to do is go into our game loop, and then after we do the canvas.fill to reset the screen, we're going to do canvas.blit, we'll blit our trainer1 image, and then the coordinates of where we want it to go. In this case, I put 0 on the x-axis and then display height minus 128 on the y-axis just to align it to the bottom left of the screen. Let's go ahead and run our program to see if it's working like we think we should. So let's go ahead and run our game. And then I get this window right here, and we can see our Pokemon trainer where we think it should be. That means that our code is able to correctly read in our spritesheet and cut out the images. Now what we have here works, and if you wanted to, you could just stop here and enter all your images by putting in the coordinates and dimensions, but that's going to come with its own problems. Other than the tedium of having to put all these coordinates in, let me show you a quick example of why this might not be the best approach. Let's say I'm working on a game and then halfway through I decide I want to have the option of a female protagonist as well. So I go ahead and update my spritesheet and then run the program again. When I start up my game again, I get this. Now the female trainer appears, even though before we had the male trainer. If I go back and look at my .json metadata, you can see why. Everything's been moved around. So if I wanted to get the male trainer back again, I have to change this. And although we only have one image here, think about how problematic this could be if we have a big project. Every time we'd want to add a sprite to the game, we'd have to call the getSprite function and go through and change the coordinates and dimensions of all our sprites. And think about if they're not all the same width and height. If you do it incorrectly, you could get a jumbled mess. So it'd be a good idea to keep building on this getSprite function we just made. But luckily for us, we have the metadata, the JSON file, and through here, we'll be able to get everything we need. Rather than getting our image through coordinates and dimensions, we want to call it by its name, because this name won't be changing every time we update our spritesheet. Python comes built in with native JSON support. So if we do import JSON, we should be able to use it to parse our spritesheet metadata and get everything we need. Let's go ahead and make a new function in our spritesheet class, which we're going to call parse sprite. The first thing we're going to need to do is open up our .json file that has the metadata. So let's go back to our init function and do a new variable self.metadata. Since I already loaded in my spritesheet file as a .png, I'm just going to go ahead and replace the png with JSON. And since file name is a string, I can just do .replace, my first argument png, and my second argument JSON. There's a couple different ways you could do this, and a better approach might be just append png here rather than having to replace it later, but since I already put .png in my main, I'm just going to roll with this for now. Now that we have the name of our JSON file, let's go ahead and open it. So if we do with open self.metadata, we can open our metadata file, and then if we do as f, we can just shorthand it to f, which is a lot easier to write. So let's go ahead and make a new variable, which we're going to call data. So we'll do self.data. We're going to equal it to json.load and then f, which is our file. What this will do is convert all the information in our file into a Python dictionary, which we're storing in self.data. Now that we have a way to access all the metadata, we can go ahead and close the file since I don't think we're going to be needing it anymore. So we'll do f.close. Since we're dealing with files, good practice might be to do a try and catch exception here since we're opening the file, but I'm going to leave that up to you. Let's go back to our .json file to see how exactly we're going to read in all this information real quick. As you can see, we have a curly brace here, a nested curly brace here, and then another nested curly brace here. The way Python's going to read this is that we're going to get a dictionary of a dictionary of a dictionary. That might sound a little scary, but it's not as bad as it sounds. Also, as a side note, this is the way that texture packer gave me the information. So if you're using something else, you might get the data slightly differently and you might have to adjust this part. So now let's work on a function that will parse our sprite sheet for us. Let's declare a local variable which we'll call Sprite. Now in Sprite, we're going to want to store all this information right here. So we want Sprite to be this sub-dictionary. If we take a look at our .json file, we have two outer dictionaries. We have frames, and then we have meta. Since all of our information is stored in the frames dictionary, we're going to want to start here. Now inside the frames dictionary, we have sub-dictionaries which are denoted by the image file's name. Once we locate the correct file that we want, our next sub-dictionary is going to be the frame dictionary right here. Now that we know where everything is, let's go ahead and parse it. First, we're going to call self.data since it contains all of our dictionaries. Now, if you were following along, the first dictionary we're going to want to access is the frames dictionary. Now that we're inside the frames dictionary, we're going to want to access the name of the files dictionary, and we pass that in as our sole argument here. Now that we're inside our files dictionary, we can access everything we need by calling the frame dictionary, and this will give us our x, y, width, and height. Now let's go ahead and retrieve that information. So since Sprite is a dictionary, we can make local variables x, y, w, and h, called Sprite, and then x, Sprite, y, etc., etc., and this will give us all the information that we need. Since I already have a function that will get the image if I give it the coordinates and dimensions, let's go ahead and use that. So I can do image is equal to self.getSprite, and then I'll throw these local variables as my argument in here. Now all we have to do is go ahead and return that image. We should be good. Now let's go back to our game file and make sure that everything's working correctly. We're going to want to make sure that we're able to go through all the different sprites. So let's go ahead and get rid of this, and then we're going to make our trainer variable a list. Let's go ahead and get the first sprite of our trainer. We're going to go with the male trainer, and if we do mysprite.parsesprite and enter the file name, which is trainer1.png, we should get the first image. Getting our sprites is incredibly easy. So now what I can do is copy this 4 more times, and then I can just simply change all the 1s to 2, 3, 4, 5. Then we just have to delete this comma here and we're good to go. Now let's go ahead and do the same thing for the female trainer, just to make sure our sprite sheet's working 100% correctly. We can copy and paste what we did with the male trainer and just change the file name slightly to adjust. Now let's go into our game loop and make a method that will allow us to iterate through our sprites. I'm going to start by making an integer variable here, which we're going to call index and equal to 0. Now let's go down here to our events. So if we press the spacebar, we're going to reassign index by incrementing it by 1, and then modding it by the length of our list. In this case, the male trainer and the female trainer have the same length, so we can interchange them. This little formula will allow us to cycle through all of our sprites without going out of bounds. Now we can just go down to our blitz statement, and then rather than trainer1, we're going to set it to whatever index we're at. Now let's just go ahead and add our female trainer. So if we do canvas.blit, ftrainer index, and then we're going to put it at 128 as the x coordinate so they can be side by side. Everything should be working now, so let's go ahead and run our program. And then here's our window. And if I press space, you see our trainer move. I do it again, and we're able to iterate through all the different sprites. Looks like everything's working. And with that said, we'll end here. You should be able to take that sprite sheet class and apply it to any project you're currently working on. If you got lost anywhere in the video, all these files will be on my GitHub, so feel free to check them out there. I hope you're able to learn something new, and I hope you're able to see how sprite sheets not only make your games more optimal, but they just make your life a lot easier. For those of you who made it to the end of this video, I really appreciate you, and if you want to consider sticking around and subscribing, I'd appreciate that too. Until next time everybody, take care.